This is an A-Tiny13, and this is a padauk PFS154. I've been using these guys for about 5 years now, and have developed a lot of boards which use them. For instance, this programming board here, where there's a very specific pinout. And the problem is with converting over to the padauk is always going to be that the pinout for this one is actually quite considerably different. So let's have a look at that. I'll just get a piece of paper and we can have a look at those pinouts side by side. Oh no. Let's just tuck him away for now, out of sight, and hopefully from now on out of mind as well. So let's have a look at these guys again, side by side. So we've got your 8 pins for the A-Tiny13, and the same for your PFS154. And familiar to anyone who's used the AVRs, you've got VCC and ground, and then you've got, well, things like PB0, PB1, PB2, this is PB3, which is a little weird, this is PB4, and this guy out here is reset, but you can also use it as a weak GPIO pin called PB5. Now, by comparison, the padauk has got VCC on this side, peculiar, ground here, and then we've got PA0, PA4, PA3, PA5, PA6, and PA7. Again, oops, that's a 7. Again, quite a weird system, but of course, the real problem is if you've got a project which already has a source of power based on the pinout, this PCB as is would cause this guy a considerable problem. So what I was thinking about doing was maybe grabbing some of these little DIP 8 adapters and various male and female pins, including a little interesting 90-degree one here, and maybe some wires as well. And what we'd probably need to do is to connect, so this would be on the bottom, and then connect it to the other side of the adapter. So to the pin 1, I probably should say this is how they're orientated, and then the ground on here to hook over to this side here. So that's what I'm going to attempt to do. I'll solder one of these Frankensteins up and see if it works. If I can plug this guy into some existing projects, then that would actually save a little bit of work in not having to design or redesign those projects based around that chip. So let's give that a go. Here's a better view of the pinouts that we need to connect, and a little time lapse here of putting that bottom layer together. So having to turn it upside down actually to make the connections, because I want the little sort of plastic bit that goes on the top of those headers to be the barrier between the first layer and the second layer. Now I'm just clipping off pin number 1 and pin number 8 because they'll be wired through to the second layer. And that's about it. Okay, before I go too much further, I just wanted to check to see if this was wired up correctly. So what I've done so far is to take off the continuance of pins 1 and 8, because I'll need to rewire 1 and 8 on the board that sits on top for the padauk. But what I've also needed to do was to make sure that the ground wire and the VCC was in the right spot. So At the moment, I've just soldered on a couple of wires, which I'll loop up to connect to the next level. And here I have my stable Joule Thief, which I'm going to use to check to see that both of these things work. So at the moment there's a 1.5 volt battery coming through, but with the booster here through the QX5252, I should be getting around probably 4.5, 5 volts. So let's just poke that into, that's where ground should be. And you can't see, we might put that in this shot as well so you can actually see what's going on. And all right, so let's try that now. So that's going to be, that's pin 8 and pin 4, the old ground and the old VCC. So 4.6 volts through that circuit, which is fine. So what I need to do now is to just plug this in and make sure that that's actually coming through those wires as well. So let's get this to the side here. So we've got the red, and we're only getting 1 volt through. Oh no, there it goes. Why is that so ratty? Let's try that again. That's better. It was just a bad connection. So yeah, around, well, 4.6 as well. So that's good. So now I'll loop those up to the new layer, the padauk layer, and then that should be fine.
Okay, second time lapse then is just about putting that second layer on. And even though this is speedy, actually should be sped up even more because I had terrible trouble actually using that third hand, and in the end had to prop it up on all sorts of things to get it going. Anyway, that is those wires, so red for VCC and the black one for ground, actually wired up to pin 1 and 8 respectively. And now I'm just going around and making all the other pins connected and putting a little bit of solder on one of the pads so I can orientate the chip and solder that one in. So that's that part done.
Okay, so here's the test bed. It's the PCB that I call stable Joule Thief, and it's in a breadboard friendly version here. So basically we've got a, well, it could be 0.9 volt, anything up to 1.5, I guess, or more. This is around about 1.4 at the moment, so it's providing 1.4 volts through to the stable Joule Thief, and then through the QX5252, a couple of diodes, an inductor, a capacitor here. What we're able to get is a stable voltage through to a microcontroller. So we'll start with the microcontroller that we're familiar with. No, that's not the one, that's the double decker. Let's go to the A-Tiny13. So we'll plug that in, and it's been programmed to provide some fading through PB1, which is pin 6. And in fact, no surprises there. That's fine. So that's a circuit we've seen working before, and I'll link that up here, the old stable Joule Thief and what it can and can't do. But really, what I'm really interested to see is, will Frankenchip work? So let's put that in the same orientation. And well, that's a bit of a surprise. I didn't actually expect that to work in that configuration because it's not syncing current, it's sourcing. I'm guessing because it's PWM, it's oscillating about a value, and that's why it's able to both sync and also to source current. That's interesting. What I expected to do was to go from VCC and sync it in, which is working. But yeah, I have to investigate why that worked when it's not supposed to be able to source current. Interesting. Got a bit of data sheet reading. But anyway, that is the circuit working. Pretty happy that Frankenchip worked. Downside is, it'll require 2 of these every time I wanted to use the padauk in a project. But I think that's going to be way more cost effective than redesigning all of these little boards that I've got to match the padauk pinout, which is, as we're seeing, quite weird. Anyway, see you next time.